This video is about mixture applications. There's quite a few different types. For example, we have investment. We're investing a certain amount of money at an interest rate. We have a percent mixture. We might be trying to create a solution with a certain strength. Cost per quantity. This is where you might have some cookies costing a certain amount per pound. Even though we have many different types, the underlying mathematics is generally the same. And one of the first things we want to look at are the rates, because we can find the rates using this word per. That's what we're going to look for to find the rates. So take a look at this investment case. We have percent, and that means our rate is 0.05, just changing the percent to the decimal. With our next case, with percent mixture, we have percent again, so we're looking at the percent here, and our rate would be 0.17. For cost per quantity, we have the amount per pound, and that gives us the rate of 250. So that's how we can identify rates as we're looking at these mixture problems. Take a look at these 5 items and decide which ones are rates. Once again, you should be looking for the word per. Look for that word per, decide which ones are rates, make a little note which ones you think are rates, and see if you get this answer. Everything except for the pounds and the hours. Now here comes our first problem. We have a lot going on here. Notice that AJ is going to take her money and she's going to loan some to her friend Christine and put the rest in an account. We will set up boxes to help us organize the information. We see there's 2 types of accounts. So we're going to name those 2 accounts. Again, one of them is her friend Christine, and one of them is in the account which has 3.75% interest. So that's how we'll name the 2 accounts. Now we're going to start with the rate, because the rate is always pretty easy to find. And in this case, we're just changing the percent to the decimal. Now all along, we want to keep track of what's behind the scenes here. We have a formula which is I equals PRT. Let's take a moment to say what that is. The I is the interest earned. That's the amount of interest we're making on our money. P stands for principal. And that's really the money that we put in. R is the rate, and T is your time. So that's our background formula. Notice that we already have our rate. That's right here. And the rate is going to be multiplied by the principal. So that's what we need for the next box. We need our principal here. And we're going to be working on figuring out what is the principal, or that's the amount of money put in. Do we know how much is invested at each rate? Well, let's see what it said. It says she put some of the money to Christine. In fact, it says, how much did she loan Christine? So we really don't know how much that is. And if we don't know, we're going to use a variable. So let's say she lends Christine X dollars. And now for the other account, it just says she puts the rest in the other account. So we'll just use another variable. We'll call that Y, X and Y, for the 2 things that we don't know. Now we need time, and in this case, it says 1 year later, so we know that the time is just 1 year. Now the last column is the product. Remember, we're multiplying principal times rate times time to get our product. So in this case, the product is going to be the interest that we earn for each one of these accounts. Now we want to make the entry in the last column. And this is an important item that's going to be the same in these various different mixture problems. We're going to ignore these words for the moment. And we're just going to multiply straight across. In other words, we're applying this formula here. So I'm multiplying rate times principal times time. And when I multiply that all together, I have 0.045x. Next, I'm going to multiply the rate times the principal times the time for our second account, and that's 0.0375y. So that's how I've got my last box, which is the interest earned for each account. Well, now that the information is all organized into the boxes, we now need to write the equations. And how are we going to write our equations here? Well, let's see what we know. It says that she has a total of $637.50 from both investments. So we have the interest from the first account, and we have the interest from the second account, and we know what the total is. So that's going to give us our first equation. We're going to say the interest from the first account plus the interest from the second account is going to add up to the total amount of interest earned, which is at $637.50. That's one of our equations. Now, since we have two variables, here's our two variables, we need two equations. So we need another equation here. So let's see what else we know. Well, here's a fact that we haven't used yet. Altogether, she has $15,000. That's all the money. Some was invested to Christine, some was put, well, I should say some was loaned to Christine, some was put in the other account. Altogether, $15,000. So we have another equation here, which is x plus y equals 15,000. That's our second equation. Now we need to solve these equations. There's more than one way to do it, but I'm going to take this one. I'm actually going to subtract x from both sides. That's going to give me y equals 15,000 minus x. We can use this expression, which is equal to y, and we can replace the y in the first equation with our expression 15,000 minus x. That's solving the two equations by substitution. So here it is repeating. We've solved for y, and now we've put this piece in place of the y. There it is right here. And next, we want to multiply through. We're going to distribute here. That will be our next step. And there it is, multiplied through. We need to use a calculator perhaps to get that product. And what do we have left? We're going to combine these two, and we're going to subtract 562.5 from both sides of the equation. If you're working this out on your paper, you should come up to the next step, which we have here. We're still trying to solve for x. Of course, we now need to divide by the coefficient of the x. That's that 0.0075. We're going to divide both sides by that, and we should come out with x. There we go. X is $10,000. Very nice. We have found x. Now, if we want to find y, we can just put this right back here to say that y has to be $15,000 minus x, which we now know is 10,000. So we know that y is 5,000. And we've just found the amount that's invested at the two different rates. That is my x and y. And now we have to write the final answer in words. And there's a couple things about your answer here, especially because this is a word problem. We want to make sure that we're answering the question asked, and we want to be sure to use all of the units. So we want to answer the question. Where is the question? Here it is. How much did AJ loan Christine? So we're looking at the table to see, well, that would be X. In that case, that would be $10,000. We want to write in a sentence. Of course, we want to use dollar signs here. Here comes the answer. Oh, where is it? AJ lent Christine $10,000. And that concludes this video on mixture applications, and we had one example in this video.